Good morning all. It's very good to be here today at JFall. And a funny fact, a couple of weeks ago, we actually didn't have any plans to visit Ada on this day. But the reason why we're here is, you just saw it on the big stage if you were there, because we won the first NLJUG Innovation Award. And besides the fame and trophy and the flowers from my wife, it allows us to actually share a story of Yolt in the past 3 years. And we could have talked about a lot of topics. We could have talked about our hate-love relationship with Cassandra. And I see a few of my colleagues that are smiling at the moment. We could have talked about our Spring Boot 2 migration or our streaming data pipeline. But we decided to start with the thing that's close to our heart, and that's with our journey with microservices, which we started almost 3 years ago. And today we will, let's say, answer questions related to architecture, monitoring, scalability with microservices and our lessons learned in the past 3 years. Before we start, let's do a small introduction. So my name is Roderick Simons. I'm CTO of Yolt, which means that on a day-to-day basis I work with engineers in the teams on IT security, IT architecture, hiring of talent, and also with helping to develop new interesting features.
And I'm Pepijn de Jong. I'm a Java developer at JDriven, and I've been working with Yolt actually since the very beginning in 2016.
So before we start with the really cool stuff, let's first take one step back and explain why we actually won this award. We do that by answering 3 questions. And the first question is why we actually are front runner in the UK at the moment. Second question is more, okay, the scale that we operate at, and also how we've scaled in the past 3 years. And the third reason why we were awarded with the prize is because of the use of our innovative stack. And there I will explain a bit about the background, why we choose the stack that we started with. So for today, before we start, I would like to do one step back and explain where we started as Yolt. Yolt is a venture of ING. And where a lot of new ideas or companies are started based on maybe new innovation or customer need. For Yolt, the primary reason to start was actually because of a change in legislation. And the name of this legislation is called PSD2, or sometimes also referred to as Open Banking. So with PSD2, banks are actually forced to open up their APIs so that trusted third parties, with consent, can access your account data. So they can get your transactions and your balances, and they can do that to create, for example, Yolt. Second topic of PSD2 or open banking is that it allows trusted third parties to actually initiate a payment on your behalf. So getting access to data and initiating payment is the scope of PSD2. So back in 2016, when we started, there was a decision being made, okay, we can wait until 2018, when we actually expect the APIs to be opened, or we can start now and be ahead of the curve to make sure we are ready in 2018 when let's say the wave of APIs, all banks need to comply with this legislation in the whole of Europe, that we are the first to actually connect. So maybe a small background about what Yolt is. In 20 seconds I got on the main stage, I tried to explain it very briefly, but Yolt is an application that allows users to manage their money. And basically by doing 4 distinct things. First, it is syncing accounts into one view and by making use of these APIs. And you can create an account overview like the one you see here, where we have different current accounts, a credit card, and a savings account from Lloyds. So the second part is actually where we allow users to see their finance in a personal and a relevant way. And this is a screenshot from our dashboard, which allows a user to actually see when a direct debit is near, or when his credit card limit is about to be reached, or if he's approaching overdraft, which we forecast. Third topic is allow the ability to do payments by making use of these APIs. So we're currently in closed alpha, and we are testing this out with our user base in the UK. And last but not least, Yolt provides you with the opportunity to actually explore our marketplace and interact with our partners And one of the partners can, for example, help you to compare your energy bill, or there are partners that, for example, can help you on home insurance. So now back to the question why we are frontrunner. We started in 2016, and we expected in 2018 that the APIs were going to become available. So the mainland, we focus on the UK at the moment. In the UK, in 2018, the APIs were ready, and we were actually the first to connect almost beginning of this year. And the Brit do things a bit different than the mainland of Europe. So they decided to actually create one standard with the APIs compared to the APIs of the mainland in Europe. So that helps us. It makes it a lot easier in connecting these APIs if they're not all different, with different interpretations. So at the moment, we are the biggest, let's say, consumer of the APIs, and we've connected now all major banks in the UK. So before we move to the second reason why we were awarded, let's show a small movie of Yolt, which gives you a bit of background. Let's move to the second reason why we were awarded, and let's try to speed a bit up so we can move to the more interesting part. So second reason why we were awarded is actually the scale that we operate at, but also how we've scaled in the past 3 years. So Pepijn was first engineer, started in February 2016, and currently we have around 6 teams working at Yolt, approximately 35 engineers, and they've developed over 40 microservices which are running in production at the moment. Furthermore, we have around 500,000 users. So we went live, commercially live with Yolt in May of last year. And we currently have 500,000 registered users that use Yolt to manage their money daily. And on a daily basis, we actually fetch all transactions. So you can imagine the amount of transactions we are fetching for all these users on a daily basis and the history that we are collecting for them. And last but not least, we scaled also in the number of countries that we've onboarded. So we started with the UK market, which is our main market, and we're currently in closed alpha for Italy and France. So the last reason why we were awarded is actually because of the use of an innovative stack. And before I will explain the decision, what led to our stack, let's do one small step back. So the goal for Yolt is to become a European money management platform. It allows users to manage their money and have only one application that they can use to manage the full of their financial life. So if you talk about European money management platform, that equals scalable to the whole of Europe. So scalability was an important criteria from the start. And also, if you intend to replace the normal banks, the front end of the normal banks, then you have to become more available than the banks. So high availability and resilience were also of priority. And last but not least, because we were going to provide the users with insights, we expected that we were going to need mixed workloads within the system. We'll tell a bit about that later. So first one of the choices we made was the choice for microservices architecture. And we all know the promise of microservices, that you can independently release, scale, and deploy your services, and it allows you to select the right tool for the right job. For example, if you talk about more the data part, it allows the data scientists or data engineers to use Python or Scala, which have a better affinity with the data domain, and other services more in Java, Spring Boot. For the orchestration, we chose Kubernetes. Back then was version 1.1, I think we started with, so it didn't really prove itself at that time, but I think we made a right bet there. And last but not least, because of the scalability and high availability requirements, we chose Cassandra and Kafka. So with this stack, we expected that we actually could conquer Europe and reach millions of users.
Yeah, but when we started out, we started with this exact stack, and we didn't have those users yet back then. We still had to prove ourselves. And for me at the time, this was quite a challenging stack, because I did not have worked with all of those techniques before, but yet we were doing it, right? And by the way, we are not using all of these techniques anymore. Most of them we do, and we picked along the way some extras, which we added to this stack. But anyway, it was hard for us. I mean, we wanted to keep things simple. The stack was already challenging enough, and we decided, like, okay, let's keep everything else as simple as possible. So what we did is we took a really pragmatic approach. We defined a couple of these microservices. Back in the day, we only had around 5 of them. And we decided to not step into the pitfall of having endless discussions about event sourcing and stuff, but we would just do simple HTTP calls between those services. And at some point, I really thought, like, this is hard. You know, it was quite difficult to work in this system where I was kind of used to work with monoliths before. It was no longer possible to actually do any simple method calls to other parts of the system, but you would have to do the overhead of doing some HTTP calls. And then your user data is everywhere. And well, you probably all heard of GDPR, but we are obliged to actually remove all the its data when a user requests it. So when you have that data across all kinds of different services and databases, then it's kind of hard to, you know, make sure that you remove everything if you want to. And then also, where in the old days you would be able to just do a simple join over multiple parts of the system to fetch your data, that also is no longer possible. And then you have your logging, which is kind of all over the place, right? So, yeah, you have to do something about that, because all these services are logging to their own log files, and in order to browse them as a developer in a way that you can understand it, you have to do something about it. And let's not even talk about security. So this actually led to the following quote of me about 2.5 years ago, I think, because I was really questioning whether we made the right decisions. We were building a system for many users with a large team, but both of them, we didn't have them yet. So wouldn't it have been smarter to just start with a simple monolith in order to actually build the features as fast as possible instead of creating all this overhead? So we asked ourselves a lot of these questions back in those days. And in this talk, actually, we're going to try to answer those questions to you guys. But in order to answer them, I'm going to go a little bit forward in time. And we're going to do that with a rocket, of course. Because at some point, we were ready to actually launch to the UK. So we launched to the UK, and that looked like this. I was supposed to have sound as well, but unfortunately, it's not working. Anyway, we went to the UK, and Yolt became quite a big success over there. So we were gaining a lot of traction, and a lot of users were coming in. We got a lot of positive reviews in the app stores. So it was going very well. And later on, we moved to Italy and France, like Roderick just told. So I think after that whole journey that we did up until the present, I think we are able to answer those questions now. So these are the questions that we're gonna discuss today. The first one is that pragmatic approach of HTTP dependencies between services, is that all right? Or should we have done something else? Should we have done microservices in the first place? Was it a good idea, or should we have started out with just a monolith? Was Kubernetes a good choice? And like Roderick said, it was version 1.0 was only half a year old, so yeah, it didn't really prove itself, at least not to us. And then, how will we solve these logging challenges, but also monitoring and alerting if all your systems are everywhere? How we're going to deal with that? So, first, the question about the HTTP dependencies. Was it all right to use them? And at some point, when we were live in the UK, we were starting to ask this question to ourselves again. Like, was it all right that we took this approach? Or was it maybe a little bit too pragmatic? And in order to answer this question to ourselves, we created these little plant UML files within all our microservices, which would show a graph of all the dependencies that a microservice would have. Because we wanted to have more insights actually to answer that question. So we created these little graphs per microservice, which was really cool because it gave a really beautiful overview of what a microservice was depending on, and but it did not give the complete picture yet. And we were still missing the big picture of all the services combined and then all the dependencies between them. So what we did is we created this job which would fetch all the plant UML graphs per microservice and would just create one big graph out of it. And when we had that, we finally had the bigger picture of the whole of the system, and this is something what it looked like. So yeah, you can have a long discussion about this picture, whether it's all right or not, and we're not going to do that. But we had two big takeaways from this, and the first one was that we saw a lot of these hard HTTP dependencies, and we were really starting to dislike them. And the other thing we noticed is that you see service 5 over there, which was our user service, and it was becoming kind of a hotspot, where we were hitting that service with, well, from a lot of different other services. So, first of all, let me explain why we didn't really like those HTTP dependencies. If you have, for example, here a request coming in on service A, and service A would need some information from service B as well, so it would do a blocking HTTP call to service B. And then service B would also need some extra information, so it would fetch the info from service C. And now we have a blocking HTTP call through 3 different microservices, which is adding latency. And it doesn't really feel like it's efficient. And when something goes wrong in service C, so service C is for some reason not able to handle this request, then it would log an error to the log, and it would return some kind of failed HTTP status. So, and service B would receive that and would log an error, and then it would return some failed HTTP status. And then service A would actually do the same. And now we have not only 3 errors in our logs for a single problem, but we also have a very unhappy customer, because it's not able to actually see the data it asked for. And we don't even know in this case if if it was really necessary to fetch the data from service C. So it's also not very resilient. And these chains can even get longer, with potentially adding more latency, and also the chances of failure or one failure in those chains is only higher, or only gets higher. So that's also not very nice. And then in theory, this could even be possible, which you really don't want to have in your production environment. So then we have the hotspot of the users. And what we saw happening is the following. Take, for example, a request coming in on some backend service. And this backend service would push some message to Kafka to some data science model. But in order to process the request, the backend service needs some information about the user. For example, the name of the user, the default currency, and the country the user lives in. So the backend service would go to the user's API and would fetch this information, and then it would pass some message to the data science model. Data science model would also need some information about the user, so it would go to the user's API and fetch that information. And then it would pass it along to model B, and model B would actually do the same. So now we have a lot of calls to our user's API, which also is not very efficient. I mean, at some point we were getting 200 TPS in our production environment on the user's API, because we're just bombarding our own service. And we're using Cassandra, so yeah, it's able to cope with those loads. But it's just not efficient, and it's also not very scalable. So we decided that it was time for action. What we said is we wanted to transition more to an event-driven architecture. And if you paid attention to the stack slide, you already saw Kafka there. But we were not really using Kafka back then for our backend services. We were only using it for our data science pipeline. So we decided to use also Kafka for our backend services more. And then we set out to ourselves the duplication of data, that's okay, that's no problem. And lastly, we came up with this concept of a user context object, which I will explain later on, but let me first show you our events. So here we have the same example again, where we have service A, B, and C. And this time, we've turned around the dependencies, where service A is no longer going to these other services, but whenever something happens in service B or service C, we are just publishing those messages to some Kafka topic, and service A is listening to that topic. So it would receive them asynchronously. And then service A would just pick the bits of information it needs from these events, and it would just store them in its own data store. And now, when a request comes in, service A no longer needs to go to the other services because it can just fetch it from its own data store. So that's lower latency. And then, when we take the example of the service C was failing, in this situation, it's not really a problem, at least in many cases for us, if service C is failing, because what would happen is the information in service A would probably be a bit outdated, but we are still able to handle the request. And we are, so that's more resilient, right? And we are eventually consistent there, because whenever service C comes up again, service A will receive those messages and will be able to process them and set the right state in its own data store again. And then we have one other big advantage that we are already making extensive use of today, which is the scenario where you want to implement some new feature. And we are gonna create a new feature service. And this new feature service would need to send out, for example, some email whenever something happens in service C. So in the old days, we would have to not only create this new feature service, but we would also have to adjust our service C to actually do some call to the new feature service to send out the email. But now, we don't need to do that anymore, right? So we can just build our new feature, we can tap into the event stream of service C, and then, yeah, we can just take it from there. So this is way better expandable. We don't need to change all the older services all the time to actually do any calls. And there the paper plane goes. So that was the first thing. And then we have the user context object. Because the user information we do need in kind of a lot of places. So we decided to take a little bit a different approach there. So we came up with this user context where we have the old picture where we saw the hotspot of the users API. But now when a request comes in on this data science or backend service, we would just fetch the information from the users API, and then we would create some user context object out of that, and we would just pass it along the messages over the data science models. And this really helped us a lot to reduce the calls to the users API. So, yeah, pretty happy with it. So, back to the question, was HTTP okay to start with? Well, I think it was fine. I think it was fine to take the pragmatic way of starting. It really enabled us to really build the features, especially in the beginning, as fast as possible, and also to prove that Yolt was really worthwhile in a functional way. But it did not, along the way, it did not fit our needs everywhere anymore. So we, at some point, started to move away from it.
Yeah, that's my cue. Let's end here. So that brings us back to the questions, and I'm gonna try to answer two questions at the same time, which are related. And the first one is, was it a good idea to start with microservices? And the second one, was Kubernetes a good choice? So I told you about the promise of microservices, independent releasing, scaling, and deployment, and also that it allowed us to possibly use mixed workloads in the system. So I think the first moment when we really saw advantages of our microservices architecture was when we skilled the teams. I explained before, Pepijn was the first engineer, but at some moment in time, team grows, and it grew, and it grew, and at some moment you notice stand-ups are becoming really inefficient, so you have to do something about this. So we decided to split the teams. So we did, and we actually created feature teams, so there's iOS, Android, but also backend engineers sitting together in one team. And we gave the teams a specific purpose and a specific focus to work on. So one team was more focusing on connections, and the other one, for example, was more focusing on the engagement. So time passed, and we repeated this. We repeated this scenario where we added another team. And actually here you can see the benefits of the microservices. The data team, they had more affinity with data, so they used the Python and the Scala to actually create the data models, where the other teams more used Java. And also they were allowed, they could release independently from each other, and it allowed teams to work as autonomous as possible. However, we found one issue, one challenge, and that's the dependencies between the teams. So we saw some teams that are having a lot of handovers, a lot of communication, alignment about the interface, and we want teams to be autonomous as possible. So we saw velocity dropping. So okay, we said, how can we fix this? For that we used the the architecture diagram, which you can see here. And actually we draw all the different teams into the architecture diagram, and this is this small piece. The architecture diagram is actually this big if you print it. And as an example, you see that, for example, the connection team owns service 9, but it was a lot of dependencies with the data team. So they had to align a lot. And as we want teams to be as autonomous as possible, it allowed us to actually observe this behavior. This is a simplified example, and move the service 9 back to the data team in order to remove the dependencies between the teams. So this worked really nice. So let's move to Kubernetes and microservices, because they are related. I'm not going to explain Kubernetes, because there are a dozen presentations today that will talk about Kubernetes. But I think one of the real advantages that we've seen in the past was it allowed to scale our services quite easily. So we decided in the beginning to use Python for our data models. And the model you can see here, it's called recurrent transactions, and it predicts upcoming direct debits for in the future. So it gets a bunch of data, transactions in, and it will give you output of a list of predictions for the coming 30 days. It was written in Python, worked quite well, but after some time we got 20,000 users, 30,000 users, and we see that the CPU of the service is going to the max, and it's not really manageable anymore. So we decided to actually scale the services, and that's really easily been done by Kubernetes. You can just give this command, and at 3 months we were at 6 of these services. If you have the privilege of a public cloud provider, you can actually also auto-scale this, of course, but this was good for us. The time continued, and after some time we actually had 12 of these instances running. We had a similar another model as well, and I think both consumed almost half the resources of the whole cluster. So we knew we had to do something about this, but this gave us a lot of time actually to change this and to write it in Scala. And now I think we have a total of 4 instances running for 500,000 users. And also, I think the benefit of microservices is also visible here, that we have one service, it's running in production, and we just create a new service next to it. We deprecate the old one, and a new one comes into play. So now get back to our question. And that's the question, should we have started with microservices? Pepijn also told about the overhead that we faced with microservices in the beginning. And if you ask yourself the question about should we start with microservices, you should also actually ask yourself the question, do we want to start with a monolith? And maybe have to break it up later on in time. And we also have that experience of breaking up, let's say, a microservice with monolithic characteristics. Because one of our services got really big, and we noticed merge conflicts, long build times, deployments becoming more difficult. So we decided we needed to split up this service. And actually the refinement and splitting of this service took a lot of time, actually a couple of months to do it. And you can see here the lines of code on the screen. They increased really rapidly in half a year, and then suddenly we split the service, and the service became a lot smaller. And this is the first step, because we're actually splitting up this service even further at the moment, so we're not ready yet. So when you start with microservices, it's really the question, do I want to invest upfront and have the overhead upfront, or do I want to have the overhead later if you're going to start with a monolith, which you maybe have to end up breaking up in a later stage?
Yeah, so a bit more present than the first quote. This one also came from me, because I was also involved in splitting up this monolith. So yeah, by now I know how hard it is to actually do such a thing. And looking back, I'm really glad that we did start out with microservices in the first place. So that brings us to our final question. How did we solve our logging, monitoring, and alerting challenges? So I'm going to talk about these topics. And first I'm going to talk about the basics. Probably stuff that all of you have heard of or have worked before. And then I'm going to move on to some improvements that we made, a bit more recent. So how we started out. You saw it in the first text slide already. We started out with ELK, so Elasticsearch, Logstash, and Kibana. Who of you is working or has been working with ELK? Okay, that's less than I expected, so that's good. So when you have these microservices, then you have the problem, like said, that you have these log files all over the place, and you need to have them combined in some view somewhere. So by using ELK, this is really a simple overview picture where we have a couple of these microservices, and they are all streaming their logs actually to the Kibana, I'm sorry, to the Elasticsearch instance. And then we are using Logstash for that, by the way, to stream the stuff to Elasticsearch. And then for me as a developer, I'm able to browse those log files in one single place by using Kibana. So Kibana is kind of the user interface to talk to Elasticsearch. But this is not enough. So if you're doing stuff with microservices, this is really a must, but this is not enough, because what you are still missing here is that you have these log lines all over the place, and you don't really have a way to correlate them between services. So what we did is, when we have a request coming in, we have some request trace ID that's being passed along these services. And at first we implemented something for this ourselves, and later on we switched it to Spring Cloud Sleuth. So now we have this trace through the whole system, and as we stream it to Elasticsearch. And that gives us a beautiful overview of some logging trace where we can see one single request trace ID, and we see it switching between different services in this case. And then one other really simple thing that some colleague of us came up with in the beginning of Yolt, and I wanted to show it to you because I really like it actually. This is just a custom built, really simple, one-page Angular app. And it's not really much more than a URL generator. Where for me as a developer, I only need to remember one URL. And then I just click the report type I want to have, for example, the errors, and then the environment, a team environment or the production environment or whatever. I can even select the service, can click show, and I will be redirected to the right Kibana instance. So it's really simple, but yeah, I still use it today, so that's why I wanted to show it. And then what we also needed, already back in the beginning actually, is some way to monitor our cluster. Right, so we need some way to see how our pods, how our services are doing, if they are running fine and which version of them is running, and how long they have been running, if they had restart, stuff like that. And for that we actually created the Kubernetes dashboard. Back in the day, like I said, Kubernetes was pretty new, and we couldn't really find an open source alternative for this that we really liked and that would fit our needs. So we built this ourselves, and well, actually up until this day, we are still using it. And we never really felt the need to move away from it. And then the last part from the basics is our Grafana monitoring. By the time we were going live to the UK, we did a lot of load testing, and then we were also in need of some more insights in the system, as in real-time monitoring. So what exactly was going on in real time. And for that we implemented Grafana in combination with Prometheus. And this is just a really simple, nice graph from Grafana, where you can see the, in this case, lack of our Kafka topics. And for the ones that don't know, a lag on a Kafka topic is something like a queue yet to be processed by some service. So what you can see here is it's staying pretty low. It's staying below the hundreds. And then at some point we really see a spike. And that also shows really beautiful how nice it actually is to have Kafka in many places between your services, because we are now able to absorb these spikes. I don't know what happened. I mean, it could be that it was a sudden spike in load, or it could be that there was some service not available for a short time. But it got processed shortly after just fine. So let's move to the improvements that we made. Or actually, we are in the middle of doing so. So we were doing all these things, and we were quite happy about it. But it was still like a Yolt-wide responsibility, this monitoring and alerting. So we really wanted to push that to the teams, because that also reflects the idea that Roderick just told about the responsibility per team for a set of microservices. And then we did not really have a full picture of the traces through the system yet. And what I mean by that is that we did have the log files with the request trace IDs, but we were still unable to actually follow the whole trace and see what exact services we were hitting, and also which database hits we would have. So there was still room for improvement. And first of all, we put the accountability for the monitoring and alerting within the teams. So we gave all the teams these monitors that they could put up at in the office, and they would just show their own dashboards on that. And we even put one of those monitors in the coffee corner, which you can see here on the right. And I actually like this one a lot, because when people just grab a coffee, they look at this little monitor and they just start talking to each other about the numbers, like, hey, we're doing well today, or, oh, it's not going so well today. But it really gets the conversation started, and yeah, I think that's really valuable. And then what we are doing currently, actually, is we are moving to Grafana alerts. Because we have been using some custom-made alerting tool before, which is again for the whole of Yolt. But now that we are really pushing the monitoring to the teams, we can also push the alerting to the teams. So all the teams can set their own thresholds because they know their services best, right? So they should be able to to set those thresholds where they should be. And then lastly, we have been implementing very recently Opentracing, which is also very useful, I think. And with Opentracing, you can see stuff like this. This actually comes from the Jaeger website. We are using Jaeger for this. And you can see here some requests coming in, and you can follow it completely over the different parts of the system and all the stuff it's hitting. And you can even see the database queries that are being used there. And when we started implementing this, I was looking into one of the, I thought, really simple traces of a really simple GET request that we actually do a lot within our system. And I thought, this trace looks way more complex than I would have expected. So at some point, I started to count all the Cassandra queries that we were doing for this single HTTP call, and I came to a whopping 19. So those are really the insights that you can get with Opentracing, I think, and it really helps us a lot to not only get the performance to a higher level, but also to get the complexity down again. The same count still where we started out with. We want to keep things as simple as possible, and we still want to do so. So this helps us with that. So to wrap up the question, how did we solve them? Well, first of all, the ELK stack, really powerful in combination with some request trace IDs, our Kubernetes dashboard, Grafana in combination with alerting, and then recently Opentracing. And this is what our stack actually looks like at this moment when it comes down to monitoring, alerting, and logging. Very happy with it, and we'll see if it changes over time. So I think that answers all of our questions.
Yeah, and if mine still works, then we can go to the next slide. Oh yeah. So I think to wrap up, we've talked about why we won the Innovation Award, because of our use of open banking APIs, because of the scale that we operate at and how we've scaled, and also because of innovative stack. We shared our journey with microservices and explained why it's good to start with microservices, or why maybe it's not as good to start with microservices. And we asked ourselves questions about monitoring, logging, and the scalability. So next year we have even bigger plans, yeah, who knows that we can win them again next year, but I doubt it, and that we will be here telling another story about Yolt. Thank you very much. So we have 4 minutes for questions. So if there are any questions, happy to answer them.
First of all, congratulations with the award. You said open banking API should be available in 2018. So when are you going to deploy more?
Yeah, so I answered that question actually also on the main stage. So the APIs are not available in the Netherlands. So when 2016, the idea was of the European Union, 2018 PSD2 will be implemented in local legislation. So we see that the bill is currently passing somewhere in Den Haag for the Netherlands. So when it will be implemented, it's not sure. But my expectation is that 2019, we see APIs in especially the Netherlands, but also the rest of Europe to be fully opened up. And then to the question, when do we come to the Netherlands? Well, we focus currently on the UK, and we recently launched in closed beta for Italy and France. And that will take a bit of time for us in the coming period. To set a retention. So we have a retention of, depending on per topic, some topics have a lot of data, we have a retention of a couple of hours. Some topics have a bit of more retention, but yeah, so after 7 days, I think that's the topic at which the longest retention data will be gone. If there are no other questions anymore. So,
what is exactly the question? Oh, that way. Yeah, of course. Yeah, that's always a possibility. Yeah, sure. And you even in the first example that I gave, where we were doing this chain of HTTP calls, you could also do something like circuit breaking there to kind of fix some of those problems. So yeah, I guess there are multiple ways to fix things.
Yeah. So we have different aspects to your question. I think if you look at a basic application logging, it's also retention. I think we have it set at 2 months or 1 month, and then we lose some of the data, which can tie you to what actions a user did. There are actually no personal identifiable information in the logs. So yeah, you should know that your user ID, UID belongs to you, so that's already quite difficult. Second is the audit logs. We need to keep data of you, that in the case of a dispute in the coming 7 years, that you told the court, okay, Yolt told me I can spend my money, but I don't have my money anymore, then we need to have something to prove that we are right. There was another part to your question, which database backup. Yeah, we use Cassandra, so backups are a bit different. We have backups in our cluster naturally, and we do backups from time to time, but it's actually a good question. I'm not sure actually what we do in the case of a backup restore, and if we can then delete all the users that did the request to delete it. So that's actually a good question. Yeah. Yeah.
How do you deal with that? If you store the data everywhere, basically?
Yeah. So that's a really nice example of more the event-driven approach, where we have a service called maintenance. It gets a request for a user that uses the app to actually get all the data. So it puts out a Kafka message on the queue, and then all services in their own time prepare the data, and they send it back. And this service then combines all data, it zips it and encrypts it, and it then makes it available for download for the user within the app. I see a sign that says end. So thank you very much. And if you have any questions, let us know.